Okay, so now, just like we've done with the ellipse and the hyperbola, let's derive the equation for the parabola. So now we have this situation here, so this is general situation that we saw this before in the last video. Okay, so I've got the same setup. Okay, so now the first thing is like we have done is before is in deriving these, we're using the definition to help us. So the first thing we're going to do is let the distance from the focus, right? So D1, right? So the distance from the focus to the point P, given that the focus is at 0, comma P, right? We're distance of P here. Okay, and this is also a distance of P. So we're distance from the vertex, right? So that's P. So the focus is located at 0, comma P, and then we have a point on the parabola, just any point, x, y. Okay? Now, distance 1 is going to be given by the distance formula, right? And so the distance from the point to the focus is going to be x minus 0 squared, x minus 0 squared minus y minus p squared, right? So we'll let this represent distance 1. Distance 2 is easy because it's perpendicular, right? So it's the perpendicular distance here to the directrix, okay? And we could just use the distance from the point P to the x-axis. We know that's just y. And then the distance from the x-axis to the directrix, as we know, is p. Okay? So this is just going to be y plus p. And then what we're going to do is set those equal to each other. Okay? So now what we're going to do is we'll set up D1 equal to D2, right? So let me do that. So we're going to do D1 equal to D2, and that's going to give us x squared minus y minus p quantity squared is equal to y plus p. Now the first thing I'm going to do is square both sides to get rid of the radical, right? So that's the very first thing we're going to do. So we'll square both sides and we'll get x squared minus y minus p quantity squared is equal to y plus p quantity squared. Now I'm going to expand everything out. So if I do that, I'll get x squared minus hold on a second. That should be a plus. Sorry, that should be a plus. Plus. There we go. Okay. So this is going to be y squared minus 2yp plus p squared is then equal to y squared plus 2yp plus p squared. Okay. Now also notice that I've got a p squared here and a p squared here, so those are going to cancel out, right? And then I've got a y squared here and a y squared here, so those are going to cancel out. Okay. Now what I'm going to do is I'm going to solve for x squared. So I'm going to add 2yp to both sides, right? And so what that gives me is these will cancel, and I'm going to add those. I'm going to get x squared equals 4yp. And that is, my friends, the equation of a parabola. Now, specifically, let's look at the p here, okay, because the p is constant, okay, the 4 is constant, but p, just so we know, p, when p is greater than 0, the parabola will open upward. When p is negative or less than 0, the parabola will open downward. Okay? And then incidentally, as you'll see in the summary, if we switch x and y, if this is y squared equals 4px, for example, then what happens is now the parabola is actually is going sideways. Okay? And then if p is positive, it opens to the right, and if p is negative, it opens to the left. Oh, one other thing that I did not mention in the last video that I want to mention now is this line here, the line that cuts the parabola in half, is what we call the axis of symmetry. So in this case here, x equal to 0, the y-axis, right? In other words, in this case, the y-axis is what we call the axis of symmetry, okay? So the line that goes straight through the vertex that's perpendicular to the directrix is called the axis of symmetry. All right, but anyway, this is the derivation for the equation of a parabola. That's where the vertex is centered at the origin.